Lesson 7.2 is differentiability again, but this time it's going to involve using a system of equations to get the solutions. We're having unknowns, A and B. We have to figure out what those values would have to be to make these functions that would not only be continuous, so no holes, and have smooth continuation where there's no cusp or change in slope. So we want to go from one function, something linear, to then, I didn't pick a good way to write this, linear to something quadratic at a point where it's going to be smooth here. So ignore that. Okay, so what we know is that, number one, they have to be continuous. So we need to make an equation that will say that. That means this has to equal this. And we're going to plug in x is -3. So that would be 2 times -3 is -6a plus 9. That's going to equal this other piece when I plug in -3 for x. -3 squared is 9 times 3 is 27b. 5 times -3 is -15 minus 2 is -17. Okay, I'm going to get this in standard form. Standard form is like ax plus by equals c, or think the first variable plus or minus the second variable equaling the constant. That's the way I like it. And so I'm going to subtract the 27b over, and subtract 9 from -17, and then that would be -26. And I'm going to leave that like that. Okay, step number 2, they must have same slope, or must have same derivatives. Derivative and slope mean the same thing. So now I'm going to take the derivative of this. And it's kind of confusing because you have 2 letters here, but 2a, that's all just a constant. So if we had a 2x, the derivative of that would be 2. If we have 2ax, the derivative is just the constant 2a. So 2a equals, okay, here, same thing, 3b, all is a constant. So I take 2 times 3b would be 6b, and then the x reduces in power. And then this would just be plus 5. And so now I don't want x in here. I only want a and b to be my unknowns. So I'm going to have to plug in -3. And so I get 2a equals -18b plus 5. Again, I'm going to get it in the same form I had earlier. So I've got my 2a, I'm going to add the 18b over equals 5. So now, step 3, you're going to create a system of equations. Okay, so I'm going to line them up on top of each other. -6a minus 27b equals -26. And then 2a plus 18b equals 5. Hopefully you remember that elimination is the easiest way. To make my a's eliminate, I'm going to have to take the whole thing times 3. And so that would create 6a plus 54b equals 15. I'll write the other equation underneath it. Eliminates. 54 minus 27 is 27b. And that would be -11. Yeah, -11 over 27. Seems like a weird answer, but I remember a lot of these being very weird fractions. And then now, since that gives us our b value, we just have to plug that back in to one of the equations. It doesn't matter which one to find a. I'm going to pick this one. Seems the easiest before I even move. So you've got options. You can pick this, you can pick this one, you can pick one of them from above. So I've got that 2 times my a will equal -18 times my b plus 5. And I would just do that on the calculator. Turn it into a fraction, but then I also have to either divide by 2 or take it times the reciprocal of a half. And so I get 37 over 6. Yuck. So that's A, and that's B. So again, your steps are to make it continuous, where you set just the normal functions equal to each other by plugging in the x. Then you'll have just A and B in it. Then take the derivative of the originals, set them equal to each other, plug in x. So you have just A and B, and then create a system and use elimination to solve for one of the variables, and then plug the other one into one of the equations to solve for the other variable.